Hello everyone, I am Abhay. Today we will discuss the virtual contest 30. Before starting, let's have a look on the standings. And if you're liking my video, do give like and subscribe to my channel. Let's move on. Uh, as we can see, many of them absorbed the contest. We have the least submission C, D, and E. We will give and focus on them. And but as usual, we will start from the A. Today I am having the Yash Kumar with me, that is CK26. As I was not able to solve the problem C, so he will help me to discuss the problem. And the main point, as many of them asked from me, like how I create this contest, how I managed to put all the 5 questions. Yeah, this is possible because of the board made by the Yash. You can check his blog entry. I will put the link in the description. He created the board problem hunter, which as we enter the usernames, he will it this bot will give us the problems of the given rating. We will also put the ratings and search the unique problems which are not solved yet. This bot is very helpful in creating such type of mashups and virtuals for practice. I will give the link in the description. You can go through this link. Before any, let's continue with the problems A. The first question was little atom. In this question we are given the board of n cross m, and we if this board is good, if if this condition hold, like the blacks, the neighbors of, like we have to paint the board with black and white. So if for the each black and white, if this condition hold, like black count of black is equal to count of whites plus 1, then only the board will be good. What we have to do is, like we have to only consider, we have to make the board good if the count of black is equal to white plus 1. So what we will do is, let's consider the board of, let's make in the red board. Yeah, this board, 2 cross 2 board. So what we will do is, we will make this black, this black, this black, and this one white. So here I can see that the neighbors of white are this and this. So count of black is 2 and count of white is 1 and plus 1. So here it holds the equation. So what in every case we'll do is, we will put in white in one of the corners, any of the desired corner, like top corner, the bottommost corner, and fill all the other corners as black. So for each white, this will hold the condition and the matrix will become the good. Here is my implementation. What I did is, I placed the white and black in the first corner. You can check the test details also. For 2 cross 3 cross 2 board, I placed the white in the first, and 3 cross 3 also placed white in the first, and rest all the blacks. Like if both I and J are 0, I placed the white, and rest in all cases I place the black color. This was the problem 1. Let's move on to problem B. Um it was a bear and poker. In this question, Nimak is an old bear. He often plays poker with his friends. So they went to casino. There are n players right now, and what they have to do is, like we are given the n integers, and we have to make all the integers equal. What we can do is, we can only multiply or divide, multiply then integers by 2 or 3, and we have to make make all the integers equal. So for that, what the comes in the mind first, like that first we have to make them equal, and we can only do operation of multiplication of 2 by 2 and 3. So let's so sorry so yeah let's first take out all the comments. For, like in the first case, we have 75, 150, 75, 150, 75, and 50. We have to make them all equal. So firstly, we will take out the common divisors of all these numbers out. Like in this case, like we have the common divisor as 25. So we will take 25 out from all these numbers. So here we will left only 3, here we will left only 6, here we left 3, and here only left with 2. So after this, we will get the arrays this. If now, if any of the number contains their factors rather than 2 or 3, means if they are multiple of 2 3, but any more number is also there, like this is only factor of 3, this is a factor of 2 and 3, this is only factor of 3, and this is only factor of 2, divisible by 2. So if any of the number, like here also contains the 10, it is the factor of 2, but it is also the factor of 5, it is multiplied by divisible by 5. So yeah, this we can't make them all equal, because this is a multiple of 5. To make them all equal, we also need here 5, we also need here 5 to make them all equal. So yeah, but we have not operation to multiply by 5, we can only multiply them by 2 or 3. So after taking out the GCD of all the numbers, we will check that each number in the remaining array must contain only 2 and 3 in the divisors, not more than that. If any of the number contains a divisor not equal to 2 or 3, then the answer will be no. Otherwise, answer will be yes, because we can convert them equal. Like here we have 2 or 3, like maximum 3, so we will multiply this by 2, this by 3, this by 2, and this by 3. So now we can see that all of these are equal. So yeah, this is what we have to implement. So let's go through the implementation first. So yeah, what I have done, yeah, I have stored the GCD, like what the common factor of all the numbers in G, variable G, and first of all I have divided the number by GCD, and now I have continuing dividing the number by 2 till it is divisible by 2, and till it is divisible by 3 I add the number divided by 3. If after dividing by 2 and 3, if the number is not equal to 1, that is it contains divisor more than 2 or 3, that is any number, so answer will be no, because we need only 2 and 3 in the remaining divisors of the number. And if all the numbers are divisible by 2 and 3 only, so yes, our answer will be yes. So yeah, this was the problem B. So yeah, let's move on to problem C. So yeah, C problem was New Year and the domino. Yeah, I am with Yash Kumar. So yeah, he will explain the problem C. So yeah, hello Yash.
Hey everyone. Yeah, hello. So let's look at the problem. The problem was that we will be given a matrix of size n cross m, and we will have to put a domino. We will have to count the number of possible ways we can put a domino of size what we say 1 cross 2 in the grid. Now there are two possibilities. Either we can put it horizontally, that is, the whole domino will be in a single row, or we can put it vertically, that is, the whole domino will be in a single column. Now additionally we have some cells that are marked by this hashtag, which cannot be occupied by any domino. So this is the restriction in the problem. And so wherever there are two consecutive dots or full stops, we can put a domino here. So let's consider an example like this. On the board you can see that this is one of the test cases, and yes, instead of the whole matrix we will have to give the answer for a particular range of, what we say, no, not range, for a particular sub matrix of size given by the corners of the query, that is r1 c1 will give the corner position, what we say, position of the left upper left corner, and r2 c2 will give the position
Uh,
of the right bottom corner.
yeah, so I guess
And we
we
will,
are. So yes, I guess we are given a matrix of the given size n cross m, and we have to
yes,
find the possible two pairs of dots from horizontal or vertical, if possible, in the given square of r1 c1 and r2 c2 column, right?
yeah, so that we can put so basically we have to find the number of ways to put that domino in that submatrix given by the query,
Okay,
right?
and a domino will occupy the two consecutive dots.
Two, yeah, either in the same row or in the same column.
Okay,
So
okay, okay.
the first thing that I saw was that the constraints for the row and column are quite small, that is only 500, and the queries go up till 10 to the power 5. So one thing that came to my mind, that if we only consider either the row or the column, then it could be solved. We cannot consider the whole matrix in every query. So what came to my mind is the prefix sum technique. So if we don't consider the whole matrix, let's say take another example where there is only a single row or a single column. Let's consider the first the case of single row, right? So here I'm drawing a single row, right? So one is here, then another is here, and then let's say here we have a hash, and then another is here. So how many possibilities are there? So one possibility is that we could take the first two, right? uh, One possibility is that we take the first two, then there is no other possibility. But if I draw another one here, let's say one more, I add one more here. So one possibility is this, and second possibility is this, and if I add one more, then this is the third possibility. So there total number of possibilities are 3. So is there any way I can get the what we say get the number of possibilities in for a single row or single column in constant time? For that, let's see if if we can use prefix sums. So the thing is that for the first cell it will be 0, right? 0 possibilities are there. Then if we consider these two, then we can see that we can put a single domino here. So the possibility is 1. Then here we have a hash. Now we cannot put any domino here, so we will keep it as 1. That is, I mean, we cannot put it here, but till now from 0th index to this index, that is 2, we have one possibility. Now let's go to next. So we'll check if we can put a domino on uh, on this. We cannot, so we'll keep it as 1. Now we are considering this range. Now we can put a domino here, so we'll increment the prefix sum, sorry, we'll increment it by 1. So the solution here will be 2. Then again we have there here another possibility, so we'll increment again, and it will be 3. So we can see that we have total in the whole row we have 3 possibilities. And if we want to take a range, let's say, let's index it first. So here, so let's say we are asked to find number of possibilities from 5th index till 2nd index, right? What we can do is, see, till 5 from 0 we have 3 possibilities, and till 2 we have 1 possibility, right? So what we can do is we can subtract 1 from 3 and we will get the answer. So let's check if it's correct. So if we see in this range from 3 to 5 fifth index, there are 2 possibilities, right? And 3 minus 1 is also 2. So yes, it is correct. So now we know that we can do this operation for a single row, or similarly we can do the same for a single column, right? So is it possible that we consider the rows independently and the columns independently? Yes, it is possible, because the dominoes will occupy either the row or the column, so it is independent. So both of them are independent. So what we can do is we can take the prefix sum of each of the row and take prefix sum of each of the column, right? And for each query we will first take the rows, all the rows from what we say r0 to not r0, the all the rows. Let's say this is the, let's take the example of the first query. So the first query is that from 1 1 to 2 3, this one. So 1 1 to 2 3, so this is 1 1, and this is 1 1, and this is not able to draw. Yeah, this is 1 1, and this is 2 3. So this is the sub matrix or the rectangle that we have to consider, right? So what I'm saying is that we can take each row individually. So we can take the first and each column individually. So we will take the first row individually, and we will pre-calculate the prefix sums, right? So we can calculate the value of for the first row, we can calculate the value for the second row, and similarly we can calculate the value for first column and for the second column and the third column, and then we can add the values, and that will be the solution. So this was the whole solution, that first we will calculate the prefix sum for row and for the column, and for each query the solution will be what we say sum of all the columns from row 0 to row 1, and sum of all rows from column 0 to column 1. Yeah, so that's what I am implemented. You can
So
see
okay.
my code.
Yeah, I can explain though. Like you are first traversing through I for full the matrix, and
Yeah,
if a of I ij and a of I j minus one, like in the columns,
yeah,
you are no, in the j minus one in the yeah, in the column. If both are dots, so you have increased the row count. For the
yeah,
columns, you have increased the column count in the C, like you are increasing the
yeah,
prefix sum in C. So
yeah.
for
I've
yeah,
shared the screen. You can see the
yeah,
solution.
visible.
So this is what I have done. For first, I have taken the what we say vectors, 2D vectors. For one is for row, and one is for column. Then what I have done is for each row, I have taken all considered all the columns from starting from index 1, because we cannot make a keep a domino in single cell. So I'm doing is, first I'm what we say updating this what we say this index by the previous index, and if this one is a dot and the previous one was a dot as well, then I'm incrementing the what we say sum.
Row for the row
Same I'm doing for the
column.
column as well. Here I'm first iterating all the columns, and for each column I'm taking all the rows starting from index 1 and doing the same. Now for each query I'm taking the input as two vectors, sorry, two arrays, for one for row and one for column. Then I'm taking the input. Now here is the main thing, that for each row from row 0 till row 1, that is the query rows, what I'm doing is I'm adding the what we say upper limit of the submatrix, that is column, the same row, and sorry, for each row from this rw0 to rw1, I'm considering the all the what we say columns with index 1, and then I'm subtracting this so that we
Okay,
get the
yeah,
range.
as in the Jamboard, you have decided that in the column you are adding this row and you
Yeah,
are subtracting this row. Like you are
yeah,
this row you are subtracting and this row you are adding, because like in the row case you have add the value of the fifth and subtracted the value of the second.
yeah, yeah,
Okay, okay,
that's the thing.
yeah, I got it. Yeah, great.
It's prefix sum only, it's just that it's 2D this time.
Yeah, you have add the upper value and
Mm,
remove the lower values so that we can get
yes,
the domino for the given range.
given, yeah,
Yeah, okay,
that's it.
okay, 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 okay. Great, great, great. So at last you have printed the answer for the each query.
Yeah,
Okay, yeah, great, great. Yeah, great question. So yeah, let's move on to problem D, which was colorful graph. So yeah, uh, I guess the we can see that there are approx in the first two questions we have the 65 submissions, and in the last three questions we have only 26, which is the less than the half. Like 40% only have tried. Let's check what is the problem D now. Problem D was the colorful graph. Like the name says, it can be the problem of the graph. Yeah, it is the problem of the graph. So yeah, let's see what it is. So yeah, we are given the you have undirected graph of n vertices and images, and so yeah, in this case, let me explain the question. Uh, we are given a graph, like we are given n cross m, and n vertices and images, and for images we are given the graph how it is connected. So it is unidirectional graph. So what we have to do is, for each node we are given a color. Let me draw this. Let me clear the frame first. So yeah, let me draw a graph. Like, can I copy that graph? Like 1 2, 1 is connected with 2, 3 is connected with 2. Let's draw it. Change the color change to black. 1 is connected to 2, 2 is connected to 3, and 1 is connected also with 4, and then 4 with 3, 4 with 5, 4 with 6, 4 with 3, 4 with 5, 4 with 6. Now for each node we are given the color. Like the first node with color 1 and second with color 2, third with color 3. So yeah, let's change the color also. For the first node we are given the color 1 and color 1. This is color 1 and this is color 2. And for the third node we are given 2 and then 4 5 and then 8. What was I forgot? 3 5 8. So yeah, 3 5 and 8. Now what we have to do is we have to check which color is connected with most of the nodes, like which color has most of the edges. Like in this case we can see that the 3 has the max edges, like 3 is connected with this one, this and this. For 3 the count is for 3 the count is 4. So for 1 it is connected with 2, so the count is 2. For yeah, for 1 it is also 2, for 2 it is 1, this for also 1, this for also 1. So here we can find that 3 color is connected with 4 nodes. So yeah, here the answer will be the 4. For let's suppose a case where 1 is also connected with 9, 1 is connected with 7, and this is connected with 8. Let's complete the graph of 9. So yeah, here we can see that the 1 is also connected with 4. So here the count is 4. So in this case we have to print, like 4 is also connected with 4 edges and 1 is also connected with 4 edges. So in this case we have to return the minimum number of count. Like here the color value is 1, here the color value is 3. So in this case we will return the color which is minimum, like here the 1 will be the answer. So yeah, this was the given problem. So but after seeing this graph, what comes in the mind, like let's make like we have to make the graph of the nodes, like edges. So instead of making the graph of the edges, let's make the graph of the unique colors. Like if both colors are different, let's make a graph. Like we are given the one like let me redo something. Instead of when I make more edges, yeah, let's change this graph. I change this graph to 2 because no, because one color is 1. And first I will draw the graph according to given. Here the value is 2, uh, here the value is 3, here the value is 8, here the value is 5. So yeah, this will be a graph, but I will not store this pair because these are same. So I will definitely erase them. I will not store this pair because one can't be connected with the same. So let's use the eraser. I will don't store this. So yeah, this will be a graph. So now I will check which number has the maximum edges. Like as we prepare the adjacency list for each number, like 3 is connected with 1 8 5 and 2. I will check the size of each color. Like which, like for 1 I have only 3, for 2 I have only 3, for 5 I have only 3. Which list has a maximum size, and print the count, which and print the color. So yeah, this comes in the mind, like instead of preparing the class graph for the nodes, let's prepare the graph for the unique colors. So yeah, for that what I did is I created the graph in the set for the unique pairs. Sorry. So yeah, first I but I have not did any BFS and DFS. I just traverse over the all the possible numbers. So yeah, let's move on from the starting one. I take the inputs from the N and M, and I created a vector A of I for the inputs of the colors. And the present bool vector is for that which color is present. If yeah, if like we are getting the inputs as 1 1 2 3 5 and 8, so we will make them true. Like we have got one color, we have got the color 2, we have got the color 3, we have got the color 5, we have got the color 8. So at the last is storing, like I have print the like last answer. So last will be an last opportunity of the color. So yeah, let's move on. Last is not decided. So yeah, last is like the maximum color which can be the answer. So yeah, in the set of adjacent ADJ, I have created a set where I will make the pairs. I will make the list of the given colors. Here I have got the U and V which are connected to each other. For that I have checked the for each color, like if u color of u is not equal to color of v, I have inserted in both of their list for each other, and then I have traversed for each number. For sz I have taken the value of sz as 1e5 plus 7, like in the question we have the range for the n and m, and a c of I as a range of 1e5. So I have taken the size as 1e5 plus 7. So I have traversed over 1e5 plus 7 for I equal to 0. If that number, if that color is present, that's why I have taken the present array. If that color is present and the size of that list is more than maximum, like currently the size is 0, if that size is more than maximum, then definitely that can be one of the answer. That color means the color I am traversing over the colors, that color can be the answer. So in the first, like I've got the wrong answers, so you can check my wrong answer, like I will display. In the first case I have just only tried this condition, like if the size of the vector is more than the max, then we will store the current index and current color, and that will be answer. But no, we can get an edge case, like we have not to check the which size is lesser than the color, but we can also check which size is equal to the which, if, yeah, same that condition I've created on Jamboard. Like if here I also one, here also one, if the board size are equal, like size of 4 and 1 is equal, then I will choose the smaller one. So yeah, in the correct solution I have also added the condition where the size of current list is equal to the maximum size of the list, and if the current color is smaller than the previous color, then I will store the smallest one. Like if the current one is smaller than the previous one, then definitely I will store the smallest color, and at last and I will print the color which have the maximum nodes. So this was the implementation for the graph. So yeah, you can like many of them not have studied the graph, so yeah, we can try for teaching them the graphs. So yeah, we will think about it. And this was, and this I have I like that the Yash with me, he solved this question with doing BFS to it. So let's have
Yeah,
the point of view of the Yash, how it thinks about the BFS during the contest. So yeah, yes.
yeah. What I have done is that first of all,
Yeah,
we
your voice
ask
is
about.
bit low.
Okay, what I have now,
Yeah,
is it fine?
yeah, it's fine.
What what I have done is that obviously the name was graph, so I thought that it will be a graph problem only.
Yeah,
So the first thing that I have done is that I have stored the graph itself,
yeah.
and
Till now,
then
I can see that you have the created the vector list, union
yeah,
type, and you have stored the pairs in the vector G, and now
yeah,
you have doing the BFS over the graph.
yeah. What I have done is that first of all, because it's a graph, I need the visited array as well.
Yeah.
So a simple BFS will work. It's just that we will have to take consider that case also where the edge is sorry the node is already visited, because in simple BFS we avoid that, we don't do anything with that node, but in
Yes.
this case we'll have to consider that as well. So what I have done is, for each connected node from this current node, I have checked the color of that node and the adjacent node, and if they are different, then I will insert that color into the set of the current node's color. I have taken a array of set
Yeah,
of
yeah. I've
10 to the
seen.
power 5.
Yeah, seen.
Yeah. So that's what I have done. That for each, I'm doing the BFS, and for each two, what you say, nodes, adjacent nodes, I have checked if they are different color, and in case they have different color, I will insert them into the set, and set will make sure that they are unique elements. That's it. After that, I have traversed the 10 to the power 5 array of set, and I have checked if current set size is greater than the I mean say answer size, that is set of with the maximum size that have occurred till now.
Okay.
So if ith set has a greater size, then the answer will be that update. I will update the answer.
Like you're
That's it.
storing here, you are getting the minimum color, like which is
Yeah,
more than the answer.
yeah. It will make sure that the color will be minimum.
Yeah. Got it.
And
Got it.
also one more thing is there, just in case there is a case that all the what to say colors are of the same size, sets are of the same size. So what I have done is I have while taking the input for the colors, I have what to say, minimize the. But yeah, that's fine. No, no, that's fine.
Yeah, you
That was
have
not
taken the minimum
required.
answer. Yeah, but yeah, it will also generate a case. Yeah, it can be, but on a safer side, why to get a wrong
Yeah,
answer?
yeah, yeah. That time.
Yeah, great. I got it. Your point. So yeah, let's move on to problem E. That is the final problem. Uh, so yeah, how many of them solve? At least 10 right and 6 solve it. So at last we can see many of them up solved that problem. Which will then be, yeah. Let's explain the problem E. So it is also a graph problem. So yeah, I have a comment. I have got a comment like today's contest was graph forces, code forces instead of graph forces. We have got the two concepts of graphs. So yeah, let's move on. So here one of the students is Vasya. He was sitting on the lecture and mentioned a string S1 to Sn, means the S string S is of size n and only consisting of letters A, B, and C. So he write the string as in the form of graph on his desk with the n vertices because he have written the full string. And for if there is condition like for all the vertices, if for all the vertices I and j, they will be connected only if s of I and s of j are either equal or they are neighboring. Either equal means they can be both A and A, both B and B, both C and C. And for the neighboring, they have conditions only like they can be neighbors only are A and B and only B and C. A and C can't be the neighbors. So for making the graph, he used this condition like if he can make the graph only and only if S of I and J are equal or they are neighbors. So after that, he have then erased the string. Then next day, the Varsya's friend Petya came to a lecture and found some graph at his desk. So he heard about the Varsya adventure, and now he have to find whether he can form the original graph with using of A, B, and C. To in order to verify this, whether a string exists as such that if the Vasya used s, he would produce a graph. So now we have to generate a string s. So for if we use that string to make the given graph, given pairs of the graph, will it be possible? So we have to decide this only. So after seeing this question and after getting this knowledge from the question that A, B are pairs and B, or C are pairs, we can get that B is paired with both A and C. So here I guess if I get a point that firstly I should place B at that points where the maximum nodes are connected. So what I did is I tried to find that nodes which are connected with all the others. Like if there are if there are two, let's take the first example only. Like n is equal to 2 and n and m given na? So n is equal to 2 and m equal to 1. So here the case is 2 is connected with 1. So what I did is like 2 is connected with 1 and leaving 2 we have only n minus 1 elements. So if any of the node is connected with n minus 1 element, I will make them b because they are connected with each other. So I will make them b. So similarly they yes, answer will be definitely yes. For the example like C, they are connected with more than like if an you can say if yeah, the explanation is quite very perfect. Like the one is connected with the 3 and you can't connect if like a triangle, if they are one edge is connected with the 3, then they have to connect with each other also. So yeah, this can't be a perfect case. For this I tried to first put all the bees in the maximum length. Like let's draw a rough graph. What I try to do is I have drawn a rough graph from my test case also. Like this, something is like this. One is connected with 2, and one is connected with 3, and one is connected with 4, and one is connected with 3. I have drawn this case for my uh, point of view, like how can I solve. Now here is 4, now here n is equal to 4. So yeah, and m is equal to definitely 4, because we have the 4 pairs, 4 edges, one with 2, one, yeah. So for this, like I will check for n minus 1. Firstly, I will check for the n minus 1, which node has n minus 1. So I will make them b, because this is connected with each of them. So now I will either make all of this, all of the rest remaining as A, or all of the remaining as B, because I know that B is connected, can be connected with any of them. So all the remaining I will, let's suppose I make all them C. So at last what I will do is, after doing, I have made the graph. So after this I will check for the pair connected components. If any of this, like we now at last we can't have A and C together and C and A together. This will create a problem. Like in any case, if we get A and C together and C and A together, then it will create a problem, because these are not numbers. And also, at the starting, I have stored the pairs as true. Like these both pairs are present. And if both pairs are present and they are neither AB, neither BA, neither CA, oh sorry, we can't take CA, neither BC, neither CB, neither AA, neither BB, neither CC, because if they are present and they are neither of these, so definitely answer is 0, because there can't be any of the other case other than this. So yeah, this is what we have implemented. Yeah, in this case also I have not used any of the DFS and BFS. So here this can be the easy problem to understand you by you. So I have taken the inputs in the ADJ vector, and the visited vector where I have make them true, make the pairs AB as true, AB and BA, like they are connected and present. And for each the list of size n minus 1, I make them, yeah, I am making the value vector for value 0, I am making them A. For value 1, I am making them B. For value 2, I am making them C. So yeah, for each value of the size n minus 1, I will make them B. I make that position at B, because it can be connected with all the other nodes. So again I will traverse, and after making the given B, I will traverse over the all the nodes, all the n. And if the current is minus 1, like if it is not, till now it is not B, so I will make them all C. I will make all C. So after making C, I will check in under C, if any of them till now is not equal to B, then I will connect, make them like if yeah, I will, it's explain this question by graph. Yeah, wait just a minute, how I can do this. Yeah, at first let's explain this also. At where is my, yeah, at first I have make the, like this only have the size equal to n minus 1, so I make this as B. So after moving on, what I have did is, if the any of them is minus 1, I will make them if the current I is minus 1, and for under, and if any I got is minus 1, I will make them 2, I will make them B. Where is the board? If the current is minus 1, I will make all as 2 as C. And after that, after doing like I have made all the C's and make them as A, I will convert this as A, because after doing what I've did is, I've converted all as C and make that value as A, and after making them A, I have traversed over the this list, the list of A, like the two list will be 1, because it is possible that it can't be connected with C, because I have not make the connection of A with C, I have make all the values C rather than this value, because and I've now I am traversing in the value 2. So if now in the tree of, in the pair of 2, if I found C, like I have this value A, I found any C, so answer will be no. and if any of the pair exists but it is neither a b b and any valid pair, so the answer is no. So here I did the value 0, and in the like in the vector a, and if I find any of the value, I am traversing over the all the values like from 0 to n and all the vector list. If any at a position I get the value 0 to 0 means a and k 2 is equal to c. If a and c and a, so answer will be definitely 0, no. And for again I am traversing to all the numbers. If I definitely they must not be same. If any of the condition is valid, 1 2 2 1 1 0 0 1 1 1 0 0 2 2, and that place that pair is present, so answer will be no. Because that in this case what I have did is, if they are pairs and the pair is not valid, so yeah, answer will be no, because there must be a edge between them because they are neighbors or either of them are same. So after, because I have taken the case of the no, if any of the cases no, not no, so definitely our answer will be yes, and our answer will be stored in the value array, which is either 1 0 and 3, and I have taken the character of that placing with character a and print that out at the last. So this was the problem A. Actually, this was the problem only got by the, like, we have to make the take the intuition of the getting how we can place B and how we can handle the A and C cases. The I guess we can have the edge cases in this case like 0 1, how we can place this. Yeah, I have seen the rest of the solution also. They all have done the depth first search in the, yeah, he has also done the DFS. Here I've also checked the solution of this. He also did the he did BFS in that. So yeah, this was a problem E. And yes, E, if you don't get any of the problem, do ask in the comment section, and do observe the contest. And yes, let's meet in the next contest that will be held today. So yeah, goodbye.